All right, so from previous video, we used rule 13 from the molecular weight of phenol. Why is it phenol, right? But let's say we don't know this is phenol. How you get to the phenol, okay? So we use rule 13 on 94. So we get to the base formula of C7H10, okay? The next one I'm going to show you from base formula how you get to the possible molecular formula, which is C6H5OH, right? That's a phenol, okay? How you get to there, all right? So here's how it works. All right, from the base formula C7H10, you can determine the degree of unsaturation or hydrogen deficiency index, HDI, same thing, okay? So this one is 3. Well, what does 3 mean? Well, gonna be a ring, 2 bonds, like that. Could be a triple bond and a double bond. It's a bunch of them. That's a possible. Looks like there are multiple possibility. Now, we're gonna need more information to help us eliminate all these possibilities. Okay, it looks like mass spectrum by itself is not enough. We have this. Ta-da! What do you see? Let's take this sample. Of course, it's phenol, but we don't know it's phenol. Okay, let's pretend we don't know. Take the IR, all of it. We get this IR spectrum. Now, what we see? So we have sp3ch. Okay, so we have sp2ch. Look like an alkene. Okay, we have an alcohol. Obviously, there's a free alcohol right here too. We have 1610 right here. Oh, so probably CC double bond. Okay, we also have CC double bond. We have overtone, looks like aromaticity. Okay, a benzene ring. Okay, so if there's a benzene ring, the minimum degree of unsaturation is how much? A benzene ring, 3 double bond and 1 ring, right? So DOU is 4 already. Okay, so right now this base formula have the DOU of 3, so you have to adjust it, right? So we need the degree of unsaturation of 4. Not only that, we also have 1 oxygen, so you have to add oxygen into it. Okay, now I'm going to add oxygen to this compound, to this formula, but you can't just add it directly. So if you add it directly, this the new formula would be heavier than 94. You can just add it directly. You have to subtract. If you add oxygen, you have to remove something. Okay, each oxygen is 16, so you have to remove 16. What could be 16 on here? So carbon is 12. 4 more hydrogen is 16. Okay, so to add 1 oxygen, you have to remove 1 carbon and 4 hydrogen. You're gonna get C6H6 and O. Do a degree of unsaturation. That's 4. Here we go. Okay, looks like if you come up with the possible structure, you can have phenol right here. You may have some other isomers. Maybe look something like this. Right, but this one have the carbonyl carbon. We don't see the 17, 15 earlier in IR spectrum, so this one probably no. Okay, for the sake of practicing, you can add more oxygen if you would like to. In case it's just for practice, we're probably gonna stop right here. All right, but if you want to try to do further, you can add oxygen, remove another CH2. You DOU of 5, but probably not going to be too large. Okay, you can even add nitrogen. Nitrogen is 14. Each nitrogen is 14. So carbon 12. 2 hydrogen is 2 hydrogen is 14. Adding nitrogen is CH2. So remove CH2. You're gonna get C6, H8, and N. If you do the DOU on this formula, you're gonna get 3.5. This is highly unlikely. Okay, you can't really have the half double bond or something, half a ring. If you can make it 2 nitrogen, so subtract another CH2. This one DOU of 4 might be more likely. Okay, anyway. All right, so we have this chart, right? But I don't want you to memorize this chart, not at all. Think about this though. This one just like subtract, add ratio. Oxygen is 16. What could add up to 16? 1 carbon, 4 hydrogen. Nitrogen, each nitrogen is 14. All right, so carbon is 12. Add 2 hydrogen, so CH2, that's nitrogen. If you want to add nitrogen, remove CH2. Sulfur is 36. Okay, so C2H8. You can do the math right there. All right, you can even subtract carbon and hydrogen. Let's say if your base formula have too many carbon, well, add remove carbon, add 12 hydrogen, or too many hydrogens, like say C2 but H20, something like that. You can add 1 more carbon and remove subtract with 12 hydrogen, something like that. Okay, chlorine and bromine, you can do the same thing. So chlorine 35, C2, H11. So combine these two, you're gonna get 35. Bromine 79, you got 2 options: C6, H7, or C5, H19. Okay, check the DOU as well. All right, let's do this. Try this on your own. Okay, we just did the use rule 13 on 58. I want you to propose the structure of this compound. Let's go.